Welcome to Unit 5 Equilibrium. This is Lesson 1, Video 1. So we are going to continue our talk a little bit from our last unit on kinetics and kind of segue into equilibrium a little bit. So with kinetics, we looked at rates of reaction. So we looked at the change in concentration over the change in time. Equilibrium, we are going to look at the extent of reactions. And with kinetics, how fast a reaction takes place. Extent of reactions with equilibrium is how far does the reaction go towards completion. So we ask ourselves a couple things based on this, or we look at certain things with equilibrium, such as what are the concentrations of reactants and products when no further change occurs? So we look at equilibrium being a state where the rate of the forward reaction and the rate of the reverse reaction reach a balance, hence the word equilibrium. So if you think about when we talked about the collision theory and the transition theory, the forward reaction is where we start. We have two or more reactants, maybe even one reactant, and it goes towards products. Well, according to the collision theory, some of those products could react together to reform the reactants. So we could have a forward reaction and a reverse reaction. And when those two rates equal one another, it looks like the whole thing is standing still, but it's not. So in some reactions, may go quickly to products before this balance is reached. So the rate is so high that it almost appears that all of the reactants have been turned into products, but there's always going to be some reactants that remain, and there's always going to be a couple products that break down and might not reach that transition state and go back towards reactants. So equilibrium, when we study it, asks two questions. How much product can be obtained from an equilibrium reaction? So if we know that we have this state, this extent of reactions, how much product can we get? And two, how can conditions be adjusted to obtain more product? So what can we do to get more product? So this is looking at more of a manufacturing situation. How can we manipulate things to get more? So all reactions themselves are reversible. And they reach a state of equilibrium. Now I'm going to start abbreviating equilibrium as EQM, because we're going to write it so many times. So this state of equilibrium is one in which the concentrations of reactants and products appear to no longer change. So this takes time after we have a reaction established. And with that, here is what these equilibrium reactions look like. So you can see that we have a reactant, N2O4, and our product is NO2. It is balanced. And you see that we have a double arrow here. That is going to indicate a reversible reaction. So that indicates that we have an equilibrium system. You might also see this as a double arrow like that, or two arrows, depending on the computer program or how it's written. So there's different ways that we can denote that.